Okay, so for this category of question, okay, we are going to do the working backwards for the type of questions that involve HCF and LCM. So the basic idea is, right, if I gave you 2 or 3 numbers, you should be able to perform the prime factorization correctly, and then you should be able to get the HCF and LCM correctly. So now it's the opposite idea. So they gave you the answer for HCF and LCM, and one of the original number is missing. So your brain has to be able to work backwards. So what will be the approach for this type of question? So if you look at the so if in this question we got 3 numbers. So I will always do something like I will just take the number, do my prime factorization. So basically I will just do prime factorization first, because that will be the same set if you are asked to find HCF and LCM. So that will be my first step. After the first step, I'll be arranging in such a way that how I usually do my HCF and LCM. So when you usually do your HCF and LCM, you will have 2 numbers. So currently 1 number is missing right now. And then the other number is 56, which you already gotten the prime factorization. So after you have gone through the prime factorization of the 3 numbers, you will realize that there's actually a factor 3. So you will be best that you leave a space for that. Then, okay, the first thing I will be thinking of will be the HCF, because HCF will be the highest common factor. That means, right, it indicates that will be the minimum for the lowest power for the 2 numbers. So actually from here, I can tell a little bit what will be the question mark already. That means, right, at this moment, I will think that, right, it should be a 2, 3, or it can be a 2, 4, or it can be a 2, 5 for this part. So it can be a 2, 4 also, because if it can be a 2, 4, you will still take 2 cube as the highest common factor. So but if it's a 2, 5, you will still take 2 cube for the family. But then, right, the question actually asks you for the smallest. So I will have chosen 2 cube. So from the HCF part, I already gotten 2 cube. That means, right, you will need 2 cube from the unknown number and the 2 cube that come from 56. Then when you do the HCF, you can get the 2 cube. Okay, then now we add on the LCM. The LCM is the higher power. So the LCM is 504. So my 504 is 2 cube times 3 square times 7. So the 7 is already here. But actually I got a missing 3 square. So where will the 3 square come from? The 3 square has to come from the unknown number. So the only way for 3 square to appear in the LCM will be it comes from the unknown number. So therefore, this is where you get your unknown number. So the other number is 2 cube times 3 square, which is 72. Okay. So in the next 2 questions, if you are at this point, if you can understand this question, you may want to try, you can pause this video, you go and try the 2 questions. Then you come back to see whether you actually get it correct or not. Okay. Otherwise, if you think you're still not confident, okay, we'll do 1 more question first. So again, right here, we got 3 numbers. I'm going to prepare the 3 numbers with my prime factorization first. So first of all, you must make sure that you got no careless mistake. Otherwise, it will be very confusing. So after the basic prime factorization, let's arrange them in such a way that we can work backwards. So m is the unknown number, and then so 364 is the other number. So 364 is 2 square times 7 times 13. So the first thing I will do again is the HCF. So I will look from the HCF first. The HCF is 52. That will indicate the highest common factor. So both of them must have the same number, at least. So I already can get something for m. Then I will explore the LCM. So the LCM is 728. So from here, okay, you got to see whether it makes sense or not, because there's actually a 2 cube. But either m and 364 doesn't have the 2 cube. So we know that just now when we observe the HCF, it should be 2 square at least. So now in this case, right, I know that it has to be a 2 cube, because this 2 cube must come somewhere. So it should come from m. So from here, the smallest m will be 2 cube times 13. So that will give you a 104. Okay, so if you think you are confident to try one question, you can actually pause and then you give it a try for the last question. And so same thing for the last question. I'm going to do a prime factorization first. Okay, so 12 will be 2 squared times 3. Then 264 will be 2 cubed times 3 times 11. Okay, so I'm assuming you can do this successfully with no careless mistake. Then we will rearrange them. So my first number is P. My second number is 264. And there is a factor 7. So I leave a gap for factor 7. So again, I will consider my HCF first. My HCF, the question says that it's 12. So, which means, right, okay, that means it should be 2 square. If P has a 2 square, then I can take 2 square as the common factor. And then 3. So both of them must have 3. Or maybe it can be 3 square also. But I'm taking the smallest. Then I get on to explore the LCM. So the LCM is 2 cubed times 3 square times 7 times 11. So if you observe, right, where does the 7 come from? The 7 has to come from P. So this will be the possible value for P. Smallest possible. Of course, it can be bigger. It can be bigger if, let's say, I have a 2 here. You will still take a common factor 3. But we choose a smaller one. Okay, so that's how you approach this kind of question.